Welcome to the new section of this course, Iterators. Now let's move on to the video, Building Your Own Iterators. Let's start with building your own iterable range. We already know that iterators are kind of the standard interface for iterations over containers of all kinds. We just need to implement the prefix increment operator, the dereference operator, and the object comparison operator. And then we already have a primitive iterator that fits into the fancy C++11 range-based for loop. In this video, we will see how to implement an iterator that just emits a range of numbers when iterating through it. It is not backed by any container structure or anything similar. The numbers are generated ad hoc while iterating. So, let's take a look at the code. In this video, we will implement our own iterator class, and then we will iterate through it. In this code, first we include the header, which enables us to print to the terminal. Our iterator class will be called num_iterator. Its only data member is an integer. That integer is used for counting. The constructor is for initializing it. It is generally a good form to make constructors explicit, which create a type from another type to avoid accidental implicit conversion. Note that we also provide a default value for position. This makes the instances of the num_iterator class default constructible. Although we will not use the default constructor in the whole video, this is really important because some STL algorithms depend on iterators being default constructible. When dereferencing our iterator, it will return an integer. Incrementing the iterator will just increment its internal counter, I. In this line, we will compare the iterator against the end iterator. If they are unequal, it will continue iterating. That was the iterator class. We still need an intermediate object for writing for, which then contains begin and end iterator, which is pre-programmed to iterate from A to B. We call it num_range. It contains two integer members, which denote at which number the iteration shall start and which number is the first number past the last number. This means if we want to iterate from 0 to 9, A is set to 0 and B to 10. There are only two member functions that we need to implement, begin and end functions. Both return iterators that point to the beginning and the end of the numeric range. That's it. We can use it. Let's look at our main function, which just iterates over a range that goes from 100 to 109 and prints all its values. So it's time to compile and execute our code. Go to the terminal, type in the command for compiling, and then executing the code as seen earlier. Cool! After the successful execution, you will get the output as highlighted here. You have built your own iterable class. Now we will be making our own iterators compatible with STL iterator categories. Whatever your own container data structure we come up with, in order to effectively mix it with all the STL goodness, we need to make them provide iterator interfaces. So let's see the code example for better understanding. For that, go to the Atom editor, open the ex2 directory, and inside that, open the respective .cpp file. Here we will implement a primitive iterator that counts numbers and use it together with an STL algorithm, which initially does not compile with it. Then we do what's necessary to make it STL compatible. Now let's understand the code in detail. First, we need to include some headers, as always. Then in a class num_iterator, we implement a primitive number counting iterator, as in the previous example. When iterating over it, it will emit plain increasing integers. The num_range acts as a handy begin and end iterator donor. In order to keep the std namespace prefix out and keep the code readable, we declare that we use namespace std. Let's instantiate a range that goes from 100 to 109. Note that the value 110 is the position of the end iterator. This means that 110 is the first number that is outside the range, which is why it goes from 100 to 109. And now we use it with standard min-max element. This algorithm returns a standard pair with two members, an iterator pointing to the lowest value and another iterator pointing to the highest value in the range. These are, of course, 100 and 109 because that's how we constructed the range. So let's compile and execute our code. Go to the terminal, first navigate to the ex2 directory, and clear the screen with the reset command. Next, type in the command for compiling the program. After the successful compilation, execute the code using this command. Nice! We have obtained the output here. So here we have come to the end of this video. In the next video, we will be implementing high-end algorithms.